Hello everyone. In this video, we are going to see the MATLAB simulation of semiconverter fed DC separately excited motor. Let us open the MATLAB and then let us open the Simulink. Now let us create a blank model. In order to draw the circuit, we need two thyristors and two diodes. So type thyristor. Let us rotate it using Ctrl R. We need two thyristors, so we can drag the thyristor to get right click and we can drag it to get the another thyristor. And then we need two diodes. Again, we can rotate this diode by pressing Ctrl R. Again, we can drag the diode to get one more diode. Then we will connect all the devices in bridge fashion. Now we have to feed this bridge with a AC voltage source. Let us take the peak amplitude to 200 and the frequency to 50 Hertz. And we will connect the AC voltage source as input to the bridge. And at the output, we need to connect DC motor. So let us type DC machine. We will rotate the machine and we will connect the armature terminals to the output of the bridge. And let us change the inductance value to 0.12. And then the field winding is fed with constant DC voltage. So let us type DC voltage and let the voltage be at 100 volts. And then we will connect the 100 volt directly to the field winding. Then we can have a constant block to have the torque input. Let the torque be 12 Newton meter. And we will connect the torque to PL terminal of the DC machine. Now we have to choose a bus selector. So type bus selector. And the input of the bus selector should be connected to the measurement terminals of the DC machine. And we'll choose all the elements in the bus and we'll add those signals to the bus selector. In order to see all the waveforms, we need to use scope. And let us take the number of inputs of the scope as 4. See, so double click on the scope and let us configure. Click on the configuration parameter properties, and let us have the number of inputs to be 4. And then we will have the layout to be 4 windows. And then we will connect all the 4 signals to the scope. The first signal is the speed in radian per second. The second one is the armature current. Third one is the field current, and the fourth one is the electromagnetic torque. Now we have to give gate pulse to the thyristors. Let us take the amplitude of the gate pulse is 5. And then time period is nothing but 1 divided by 50 hertz. Let the pulse width be 10%. And let us take the phase delay to be 30 degree. So 30 into 360, 30 into the time period, which is 0.02 divided by 360 is the time equivalent of the 30 degree. The output of the pulse generator is connected to the gate pulse of the two thyristors. So the two thyristors are connected to the pulse generator, where we have typed the delay angle to be 30 degree. Now the circuit is ready to run. Before running the circuit, we need to place a power GA block. And let us first run the circuit with a stop time of 1. Let us check the waveforms. So these are the waveforms which we got when we run the circuit for 1 second. And let us change the stop time to 5 seconds and see how the waveforms are. So we have obtained the waveforms which are obtained like this after running the model for 5 seconds. The first waveform shows the speed of the motor in radian per second. And the second waveform is the field current. This one is the armature current. And the electrical torque is the last waveform. The electrical torque, it is coming around approximately equal to the set value of the torque, which is 12 Newton meter. So in this video, we have seen the simulation of single phase semiconverter fed DC separately excited motor. And we have obtained the simulation for an input torque of for a load torque of 12 Newton meter. And the waveforms of speed, armature current, field current, and electrical torque are obtained. Thank you.